Welcome, everyone. It's our first and last class of this week. So Thursday's a holiday, uh, so we'll take that break. We have left, first of all, I have posted all the scores for the exam 3. However, I've not posted the actual exams themselves yet. Two reasons: I need to get the scans done, and I was grading till late Sunday night. So those scores are at least posted. I will get those uploaded probably Thursday morning. Um, I have a few makeups to do today and tomorrow, so we'll get those taken care of for students who were sick. Um, so that takes care of that. So they'll be uploaded Thursday. Overall, good results. Again, it's all individual. So you'll be able to see your own. There were a few questions that if you got the wrong start, like that U substitution one, it was hard to get much points because nothing really worked out, right? So just take a look at those. Again, review. You can use that to review for the final. I've actually, we're now in this journey to the final section. So today we'll do the average 14.3. Tuesday we'll do 14.4 surplus, and then we'll do 14.5 on Thursday. I'm willing to do a review session maybe during finals week, maybe that Tuesday, maybe Monday or Tuesday or Wednesday. I'll be dependent upon what kind of requests I get. So if again, you don't have to do it right now, but maybe next week start thinking if you'd like a review, suggest some times. I can do it Zoom. I can get a room for us, a larger room, maybe during finals week. Although a lot of them are being used, we'll see if we can do that. But Zoom office times may work out well, but we could do a 1 or 2 hour session, maybe between the two classes on Zoom would work out well. But again, I'm happy to do that. There are a lot of resources in here with many of the questions, if not all of them. It's been a while since I did some of these, but there's solution videos in here. There's PDF solutions to all the 3 exams. Again, they are from the solutions are from spring semester. I'll get the ones for fall posted over the weekend as well. So there's these things to review. There's video solutions. There is a complete review for the final exam. And what they did is they incorporated a lot from the first 3 reviews, and then because that's basically you got your first 3 exams, right? And then you have just 3 new sections. So basically, you can expect probably a question from each of the new sections, plus a few from scattered for all 3 tests. It's only a 2-hour test, only, but each test has been 50 minutes, an hour, let's call it. So, that's 3 hours of tests for just those. So it won't cover everything to the same extent. It generally will be about one of the midterm tests and a half, maybe. So it's not quite double. As I get the final, I'll be able to give you more details next week. But again, it's a good time to start into the review, see where you're at, and then there's also these solution videos for what we're doing today. Okay, so 3 more sections, but they tie in a lot. Especially you're going to see today. There's really nothing new, but except you're going to get to practice with the FTC, the fundamental theorem of calculus, which is to integrate it between 2 parts. There's just one added thing, and let me just put it this way. If I was driving my car for 2 hours, and in that time I went 300 miles in 2 hours, what was my average speed? Oops, let's back up a little bit so I have these. Let me write that down. Okay, so in 2 hours, I drove 300 miles. What was my average, right? That's what we're doing today, averages. Speed, whatever. Anyway, how much? 150. I was moving along, so maybe I was in the. So how'd you get that though? You took your 300 miles, you divided by the 2. And actually, I'm going to do this a little different, 2 minus 0, because what I'm really asking is from the start to the 2 hours, right? Starting is always 0. So I want you to think in terms, because that's what we're doing today, is we're doing this exact thing. What is the 300 miles? That's a distance. What's going to change today is they will give us a function for the speed itself that maybe varies and want us to get the average speed. The way we do that is we integrate the velocity, and what do we get? We get distance, and then we divide for how long it's been going, and we will get the average speed. So average, what we're going to see in this case is we're going to integrate the velocity function, which might not just be, I'm driving 55 miles an hour, whatever. Uh, and again, this was, 150 miles per hour. We're going to integrate velocity from start to finish, so A to B, and dt. So that's going to give us the position function, which we always called S, and we'll take that from A to B. That's the fundamental theorem of calculus. What we're going to add to that, since we want the average, right, because this would give us the total distance. Knowing the speed, it would give us a total distance from A to B, from time A to time B. To get the average speed, we're simply going to divide by B minus A. So this little green thing, that's the new stuff. So we've already been doing this to get total distance. To get the average speed, remember, because this changes, we're dividing by the time, so it turns it back into a rate, but it's an average rate. Okay, so we start with a derivative, we integrate it, we get a total amount, and then we divide by the start to the finish. We end up with a rate again, but an average rate. Okay, we can also apply this to things like cost. If we given the marginal cost, we integrate it, we get the total cost, we divide it, and then now we're back to an average cost. So that's what we're doing today, and you'll see it's as long as you just sort of follow through. This part in red is what we've already done, and we're just going to, it's just this little extra, okay, multiply by this. I remember learning this, it just seemed like it was too simple for me. Why did we spend a whole day talking about it? Because it seems like, well, it seemed obvious, and it is. But so it's kind of just take it. You'll get some more practice with the integration part, okay? And so let's kind of go ahead. But that's basically all we're doing. So that natural thing of, this is my distance, divide by the 2 hours. That's really all we're doing to get an average speed. Now, doesn't mean I was, this case going at 150 miles all the time. I probably was going faster and slower, and that's the thing that happens. But the average speed would be that. So thinking of what an average is, I ask you to average some numbers. You add them all together, divide by however many numbers there are. So here's an example down at the bottom. Here's 4 numbers. To get their average, you add them together, divide by 4. That's just to kind of get you to think, how do we integrate? Remember when we were doing Riemann sums, area under a curve, we added together all the rectangles. What we would do now is we would divide by how many rectangles there were, and that would give us an average. And we're going to see what that means is it's sort of the highs and the lows average out. So we've just got a nice little compact rectangle, okay? So we'll show you graphically what's going on, but it's just that's all we're doing, okay? So it's this, if it feels like too good to be true, It is. It's actually one of these things that is fairly simple to get the average. Okay. So here's an example of something with a varying velocity. So over 2 hours, my speed is varying. It's going between 50 and 60 miles per hour. And they use this function, which is valid for between 0 and 2. So it's a quadratic, so maybe I'm going faster, slower, whatever. But what I want to find is what's my average speed, right? I've got a rate. How do I get distance? I integrate, right? I integrate the velocity. I will get the distance. Then to get the average, I just divide by the 2 hours. So what that looks like is I'm given a function, 50 plus 2.5 t squared dt, and I'm going from 0 to 2. That's going to give me the distance I cover in 2 hours, right? When I integrate it, to get the average speed out of that, I need to multiply by 2 minus 0, which is just 2 hours, right? But I could use this if I want to know the average between 1 and 3 hours or something, So that's why I want you to see it's not just that we're dividing by 2, it's really 2 minus 0, and that will help you in the general form. So how do we integrate this? Well, 50 integrated becomes what? 50x, or 50t. I like x better. Let's just change this all to x's, because my t's look like plus signs, right? So we could do that. Just remember, when you're doing WebAssign, you may have to change it back to t, because they'll usually say it's wrong. How about 2.5x squared? Well, we know the x squared, we're going to add 1 to the exponent, so it's going to become x to the third. So 2.5 x to the third divided by the new exponent. Okay, so notice how we will get practice with integrating, which gets back all the way back to, 13.1, when we first started doing this. So we're getting the antiderivative. Now, here's the fundamental theorem of calculus. It says we don't have a plus a c, we go from 0 to 2. And I did notice on the test, some people didn't know what the fundamental theorem of calculus is. I know sometimes if I would have shown you, you'd know what it is, but maybe using the name. But this is the fundamental theorem of calculus. And again, since we want the average, we're also sort of, once we do all that, we're going to multiply by 1 over 2 minus 0. And I'll keep writing that 2 minus 0. It is just 1 over 2, but I want you to see how we got it for the instance when we don't start at 0. Okay, so now we can integrate this, right? And here's the fundamental theorem of calculus, right? We plug the 2 in for x. We plug the zeros in for x. I think I've got something coming here, but I can erase it if I need to. Let me just go 50 times 2 plus 2.5 times 2 to the third, which is going to be 8 times that, divided by 3, minus, now if I plug in 0 for x, both of these become 0. So I'm just going to shortchange it by, or just put that whole back part is 0. But that's the fundamental theorem of calculus, right? Plug in the upper limit and plug in and subtract when you plug in the bottom limit. Okay. So again, practice with this part, because this gets us back to 13.1. So more practice. And then again, once I get my answer, to get the average, I'll simplify it a little bit. 2 minus 0 is now just 2, 1/2. So I just divide by 2, multiply by 1/2, divide by 2. 50 times 2 is 100. This is 8 times 2.5 divided by 3. I think it's like 6 something from, because I did this yesterday afternoon. Let's see, 2.5, 2 to the third is 8. And then we divide that by 3. Yeah, 6.6666. So we'll call that 6.67 minus 0. That's not going to do anything. So this is 100 and divided by 2. This is 106.67 divided by 2, which is going to give us an average. Let's see. 106.67 divided by 2, about 53.33. 34 if you want, whatever. It's close enough. 53 miles per hour average. And doesn't that make sense? If we're driving and we're staying between 50 and 60, our average should be somewhere there in the middle. That's what the average is going to be. So we're on track. But notice how the process is what we're focusing on. We're given a rate, we integrate, we get the number of miles traveled, and then we divide by the interval of time, the 2 hours average. And it's yeah, let me go back and erase all my writing because this is going to do it. At least this part. There we go. And don't worry too much. The textbook is going to walk through this step by step, but I just feel it's better to talk and write through it as we go. So yeah, we're going to integrate the velocity function. I'm not done erasing yet. Oops. Give me my eraser. So again, that's what we had as well. And then when you integrate it, you get the 50t or 50x, 2.5 over 3, t to the third. We got that. Take it from 0 to 2. They left it as a fraction. And then they put it, that's what we got, 106.67 miles. And then they talk us through, well, we've traveled over 2 hours, 0 to 2 hours. So we divide by 2, just like we kind of thought before. And that gives us an average of about 53.3 miles per hour. I may have rounded that up to 3.4, but I was wrong. Anyway, okay. And so then they say, well, why don't we just start off with it? If we know we're going to get the average, let's do it at the beginning. So they kind of, the first, when they talked us through it, they said, okay, let's just integrate and we'll get the miles, then we'll divide by 2. So this is how we sort of start off with the formula for average. So watch for that. It really is just a simple concept. We're getting the total, dividing by that interval. And again, to me, it just seemed like we're going over this interval and then we're doing this. Again, it seemed too simplistic. There must be something wrong with it if it's simple, right? But this is one of those, it is. It is, getting the average is you're just dividing it out, okay? Let me show you, I don't think they show the graph, so let me do that. We're going to take some look at some graphs anyway, but it's actually, I mean, we're pretty much done. We're just going to look at some more examples. But let me graph this derivative for you. Oh, it's still loading. Okay. Hopefully it's load. Yeah, here we go. We're going to graph it and we're going to see what that basically we get the area under the curve, right? When we integrate, we get area under the derivative curve. That's what the visual is. What the average is going to do is it's going to take the high points and put them with the low points and just make basically a nice little box. So I'm just going to put in the formula they gave us. It was 50 plus 2.5 t or x squared, right? Remember it correctly. So that was the derivative. So we're actually graphing the derivative. The question said we were going for 2 hours, so 0 to 2. I'm going to set up my window to see it nicely. So let's go from -1 to 3. I just kind of want to zoom in on it, but I'll see enough. And then remember my speed. They told us our speed is averaging from 50 to 60. So I'm going to have my Y window open up at least to 70 so that I can see everything. So I'm going to come down here. Let's say Y max is 70. This will give me a large enough window. And if I didn't know that, I would graph it until I could see the whole thing. And yeah, I can pretty much see the whole graph. Uh, I can't see over here, but remember, we're just going to go from 0 to 2. We're going to integrate this, right? And we do that with the calculator. We do second calc, number 7. And we are going to go with the lower limit of 0, the upper limit of 2. There's our 106.666. Remember that integration, the area under the curve of the derivative, that is the total distance covered. We divide that by 2, right? And we got 53.3, okay? What I want to show you now is look at this. This is not a rectangle. We're actually going a little bit faster, so we're getting more area here. What that rectangle, what the average is going to do is we're going to see it turns this same amount of area into a rectangle. So what we graph here as the average is y2 is 53.3, which was that total area divided by 2. And when we go back to the graph, look at this area under the red curve of the red line. This stuff that's above it will fit in what's below it. And I'll show you that because the area under the curve of y equals 53.3 should be right, 53.3 times 2, because it is a rectangle. Second calc, we're going to get the area this time under the new curve, under the red curve. So notice up here, I'm still on the old curve. I arrow up. I am now on the red curve, the y2. And I want this one, the lower limit, to be 0. I want the upper limit to be 2. And there's it is, and it is 106.6. So the average, that's all the average is doing, is it's taking the area under the curve and say, let's tuck the high ends into the low ends and let's just make a box out of it, a rectangle. That's all the average does. So it's kind of, and again, if it doesn't really make big sense, just remember, integrate it and then divide by the 1 over the limit subtracted, the length of the interval. You'll get it all the time, and then you'll pick up. But this is physically what's happening. It's just averaging it out. Okay, and that's what the average represents, the 53. And what this curve represented was actual speed, right? Low of 50 up to high of 60, but just averaging it out. So that's kind of cool. And we're going to look at a couple other graphs that they have for us. And then we're almost done, get some practice at it. So here's our average velocity. We do this sort of thing. And here they give us another example. So on this one, we're taking the function. The function they give us is f of x equals x, or it's really the function y equals x. If you remember that one, that's a graph of a straight line that goes up like this. And you'll see, I think they actually will show us the graphs of this, so we'll let them do that. But we would integrate it, so f of x is x. When we integrate x, we add 1 to the exponent, so we get x squared over 2. We go from 1 to 5, and since we're asking for the average, I got to get my words right, we take the 5 minus 1 in the bottom. We're going to divide by that, okay? So these are the sort of the calculation steps. Plug in the 5, plug in the 1, subtract them. So 25 halves minus 1 half would give us, right, this part's going to be 24 halves, which is 12. 12 divided by 4 is 3. Okay, so that's that connection. What is 3? 3 is the average. It's the average of what's happening. Okay. So here it is. Here's the graph. The actual function, right? This is y equals x. Looks like this, kind of triangular at the top at least. But what did the average do? It just sort of geometrically turned it into a rectangle. It took the area that was above, put it below, and just makes a rectangle. So it's kind of giving us our average. And we use averages for various things. You know, we have various, your business, how much did we sell? Well, some days we sell more, some days we sell less. But a lot of times we just want what was the average for the week, right? So we can compare week to week. And we know we're going to have high days and low days, but sometimes we don't know which one's going to be the high day or low day because things happen, right? But if we have that average, a lot of times that's helpful. You want to calculate your salary and you work on commission. What's my average? Okay, that's kind of what I can count on, right? I know some months I'm going to make more, some less, but I can average it out. So we use averages for various things, and this is all that happens. If we've got a function that even varies some more, like this one is maybe some kind of a polynomial function, we have highs, we have lows. The average just says, okay, let's see this. Let's level everything out. I guess I didn't use this on yesterday, but it's like if on the exam, right? We all scored at different levels. What if we just say, okay, here's the average. Let's take the highs and give them to the lows, and that's if we kind of were a completely egalitarian society, we'd say we got overperformers and underperformers. Let's make it all equal. We'll give you all this, the average grade. That's what an average is. If I were to take all the high points and low points, balance them out, that's what the average is. Of course, we use it. Okay, if that was the average, did I score above average or below average? But remember that average is just what everyone did in between, the highs and the lows, bringing them together. And that's all that's happening. So graphically, it looks like this. And so let's look at this example because there's one in the homework. The last homework problem is actually just like this, except it has a different interest rate. So we'll look at the formula that you'll need to use, the integration, and what we do here, you'll be able to directly apply it. So we've got a savings account at the People's Credit Union paying 3% compounded continuously. So we're going to bring in the continuous interest formula. At the end of the year, you get a bonus of 1% of the average balance. So that's an average over a year. So notice our balance will start out at 10,000. We'll get interest, and it'll be a higher balance at the end of the year. But since it's continuously compounding, it's growing throughout the year, but we want the average balance. Okay, so the way we do this is the accumulated value at any given point is the initial deposit, e to the RT, and you might remember this as PE to the RT. P is principal, whatever you deposit. So this is the formula we're going to use. We said if we deposit 10,000 at the beginning of the year, how much interest and how large a bonus will you get? Okay, so the interest earned, we can plug this in. It's going to be 10,000 is the initial deposit. R is the interest rate, which is 3%. So that's going to be 0.03, that's 3%, times T, the time, since it's 1 year, we'll put that times 1. This will give us the balance after 1 year, right? We could put, yeah, because this is not a monthly, it's an annual rate. So let's go ahead and do that. That's 10,000 e to the 0.03 times 1. And I get that what we end up with is $10,304.54. So the first part of the question is we deposited 10. This is what we have at the end of the year. So we subtract the 10 off, and we see that our interest, the interest earned, is $304.54. Okay, so we get that interest. Good. But at the end of the year, we're also going to get a bonus of 1% of the average balance. So how do we get that average balance? This is, so far has just been algebra. To get the average balance, what we're going to do is we're going to take our formula, which is is really a rate of change. Make sure I have enough zeros. E to the 0.03 t in this case, and we're going to go from 0 to 1. We'll put our dt here. Since we want the average, we're going to take 1, the endpoint minus the starting point. And you'll notice we're just dividing by 1, right? 1 minus 0 is still 1. 1 over 1 is 1. So in this case, you could not even know that you're getting the average, but that's what we're getting. So if they went over 2 years, it'd be 1 over 2 minus 0. So anyway, this is going to give us the average, and we integrate. So e to the 0.03. So 10,000 is a constant multiplier, right? We have that. When we integrate e, we get it back 0.03 t. But if you could use the shortcut rule. This was where it applies. Or you could use the u substitution, but that's a lot of extra work. You'll notice you'll have to divide by 0.03. And I do it because if you took the derivative of e to the 0.03 t, right, you're going to have a 0.03 coming down. And so when you integrate, you need to make sure, because it's not there, that you divide it out. So that's a little bit of the practice we get there. And again, we're going to take this using the fundamental theorem of calculus from 0 to 1. So we plug in 1, get a value. We plug in 0, get a value. Subtract those two, right? And then since we want average value, we're going to multiply it by 1 over 1 minus 0, which is, again, just 1. So in this case, it's not important. But in a different setting, had we had different boundaries, to get the average, it might be 2, 4, something, okay? So we plug these values in, and I think they're going to work through it. But in the end, I guess let's go ahead and do that. Because part of what I want you to see is the steps, right? So that, because in some of them, in doing this, in the test, I didn't always see it done. So we're going to plug in 1 here. So that's 10,000 e to the 0.03 times 1 over 0.03 minus 10,000 e to the 0.03 times 0 over 0.03. And then all of this times 1 over 1. I'm going to drop it now because, okay, yeah, we're just multiplying by 1. But remember, if it was 1/2 or 1/3, we'd have to take it along. We plug these in our calculator. And I'll do it visually because I think sometimes that's the problem, is we're going 10,000. You could actually factor this out as well. Second e 0.03 times 1. Make sure that's all happening up there. And then we're going to divide this by 0.03. I'll show you what that is. 343,000. We're going to take that answer and we're going to subtract from it 10,000. E to the 0.03 times 0, which is 0, but that makes that 1, right? So there we go. And then we're going to divide this by 0.03. And we get 10,151.51. And what is that? We divide it by 1. It's not really the average yet, so we divide it by 1, but that actually ends up being our average. That's our average balance for the year. Okay. If we did this over 2 years, we'd have to be sure to divide it by 2. Okay, so that's our average balance. How much bonus did we get? Let's take that answer answer times 0.01 to get our bonus. Oh, cool, we got an extra $100 bonus. So we got about $304 in interest, plus we got a $100 bonus. It's like 400. It's like we got 4% interest, a little bit more than 4% actually. Okay. And again, the last problem you have in the homework, and we'll take a quick look at that, is this same problem with different interest rates. Okay. And what I'll do is this thing's going to work it all out for us anyway. So you took the formula, you plug in 1, and that's the amount. Subtract the 10,000. There's our amount of interest earned. That was part of the question. To get the average, we're going to go from 0 to 1. So this is what we did. Again, we worked through this. They factored it out, 0 to 1. They did this part. That gave them 10,151. Same thing we got. Dividing by 1, and then multiply that by 0.01, a bonus of $101. Okay. And then, you could look at this same problem. What if we went from like year 2 to 3? The working out would be all the same, except we'd have to be sure to divide by those limits. Okay. So what I'd like to do, it's only 8 o'clock. We got done quickly, but then this gives you time. If you have any questions about previous exams or anything, you're welcome to do that. Let's go into WebAssign. I think there's 6 questions, if I remember correctly. And I just want to show you. The other thing, maybe I forgot to mention, but the homeworks from the start, I've got them all extended to December 8th. Our final exam's on December 7th. So you've got basically this last part. We're just looking for December 7th, the final. Get ready for it. Do well on that. That's the goal. Regardless of what's happened before, let's focus on that. Of course, if there's some things in the exams, I'm happy to talk to you because, again, to get through 200 exams in a weekend, I can only spend about a minute and a half on each exam. So I'm looking through real quickly. I'm just be honest, I do miss things. If I don't see something real quickly, I might not be able to give you the points. We've talked together and I say, oh yeah, I should have picked that up. I can give you full points. And I'm happy to do that. I want it to be accurate. So take a look at your exams. And then again, when I get exam 3 posted, take a look at that too. But that's one of the only way I really have to do this is to get you to come to me. And, I try to look for as many points as I can, but at the same time, I am moving quickly. So where are we? We're in, wow, these are all messed up. Where's 14? We're in 14.3. Okay, that's right. I was looking for 14.1. There is no 14.1, so I don't think. Yeah, so there's just 6 questions here. Now, what they're going to do is they ask you to find the average. So they give you the function. We're going to integrate that, right? We're going to take these as the limits and take its average. And then you have to see which graph represents that situation. So you could, just like we were doing on what I did, right? I graphed it, got the area, divided by the limits, and that gave me the average. So you can actually graph these. And if you graph it, you'll just be able to pick the right picture, right? So you don't have to try to look now and see which one fits. Go ahead and work through the problem. Graph it, right? All you have to do is graph this as y1, take its limit from 0 to 2, take that, divide it by 2. That'll give you your average. And you'll have the graph and just visually take a look. Also, they give you the windows here. So their window going from -1 to 6 in the y direction, from 0 to 2 in the x direction. So make your window in your calculator the same thing, or on Desmos. You could use Desmos on these, and you'll be able to match up. Here's another one with a different function. Again, from 0 to 1, they give you the windows, you find the graph. So there's two parts to this. E to the x, integrate it from 0 to 3, find its average. So you're going to be dividing by 3, right? Pick the right graph. Here's another one, e to the x, different limits, find the average, pick the graph. And then there's two word problems. Notice this last one, number 6, interest compounded continuously. 10,000 is the same. This one's at 4%. So your numbers here will change, but that's exactly the same question we worked. Okay, you'll just have different values kind of follow through. There you go. This one is a cost function, and you're trying to get the average cost. Again, the same thing. You're going to take that cost function, you're going to integrate it over the limits that it wants during the given period. In this case, they do want, it looks like they want you to go from 0 to 20. Be careful. I saw that there was some confusion on the exam. They wanted it like from 2009 to 2012, but up above it said this function's good for years 0 to 7, and 2007 was a starting. So what you wanted, the limits ended up being from 2 to 5, because 2009 was 2 years after 2007. 2012 is 5 years. But some of you went from 0 to 7 because it was up there. But just, carefully see. Sometimes it's hard to tell what was the average cost of Super Bowl during the given period from 1980 to 2000. So we'll use 0 to 20. Again, you'll integrate it, find the average. This one, we just have to find it here. But that's our questions. And again, it's just a simple integrate it. Well, simple. But might be simple by now. If it's not, it's a good time to practice it. But the end is we're doing something we started off in 13.1, doing the integration. I think by 13.4, whatever the fundamental theorem of calculus, we brought in those limits that we could actually get an exact value. All we're adding is we divide by that interval length to get an average. Okay, so it's kind of strange, but what we've got is we start with a rate, we integrate it to get a value, we divide by the interval, which gets us back to a rate, but it's an average rate. Okay, and again, so these are things that are different. And when you're in a business, the important thing is that you make good decisions based upon the data you get. You, in whatever role you're in, you may not be the person doing the math. You might have people and assistants do that for you, but you've got to interpret it. And you've got to be able to know that when you have an average, what that means. It means some days are going to be higher, some days are going to be lower. And, if you're talking cash flow, the lows sometimes make a difference. If you don't have enough to pay your bills, like our US government, at certain times, right? Your credit rating gets dropped and bad things happen all over the place. Just because, we'll have it next week. Sometimes creditors don't care about next week. They want it today. I don't know why we live in this kind of world that, hey, just wait a week, no big deal. But some people, it's a big deal. So you've got to make these decisions. And just because you said the average is good, we'll be able to pay all our bills. Well, maybe not. Maybe there's, you got to say, hey, you got me an average. I want to see the numbers day by day. So you got to know the right questions to ask. Or if you're like me, I was an assistant. I needed to anticipate the questions my boss was going to ask, because I know he was right on top of everything. I bring him numbers and he'd ask this, this, this. I got to the point after working with him for a while, I knew what questions he was going to ask. So I said, okay, this, this, this. I knew you were going to ask those. So I got them ready for you. That's why he liked me. Okay. When I left, he had to hire 3 people to do the work, because I got so good at getting things ready the first time. Everyone else had to learn it. And so it took them 3 times to get things right. So you needed 3 people to do what I was doing, but it took me a time to get there. So that's what I hope you get out of this class as we start wrapping things up, is the ability to make decisions from these numbers. Hopefully it's all making sense and you can do some of the calculus. Will you be using calculus day to day in whatever field you're in? Probably not. Especially as you move up into management of something, you'll be hiring people to do the math or to process this stuff, but you'll still be the one making the decision, and you need to know what these numbers mean. Okay, and that's what this gives you an experience with. When do I have a total? What does that mean? When do I have an average? What does that mean? When do I have the specific values day by day? What does that mean? Okay, how do I make my decisions? All right, I stretch it as far as I can. So, any questions at this point? Okay, so work on averages. We do have, any of you doing economics? All right, so good. We're going to need your help next week because I am not real good at economics, but we're doing something on consumer surplus, producer surplus, and that's when you charge a lower rate, you leave some more money in the economy and stuff. So you guys will probably be good at interpreting it for us, but we'll do that on Tuesday. That's kind of the last biggest unit. The 14.5 isn't too bad, but we'll just keep moving forward. And again, start your review to get yourself ready on anything else that wasn't real clear as we move forward to that final exam. It Yes, in a sense that it will be new questions, but they will take similar type questions. Um, yeah, and then there'll be some questions on this new stuff, probably one out of each section, I would say, and then it'll be a rehash of the last 3 exams. You're welcome.